work and energy. In ordinary language, work means any physical or mental activity. Like studying would be considered as work, pushing a cart would be considered as work, running would be considered as work. But however, in physics, work has a different meaning. In physics, work is done only when an object undergoes displacement. And for an object to move, you require force. So in physics, work is given as force into displacement. So if a student is at his desk and preparing for an exam, he may work the whole night, but in physics he has done no work because there is no displacement. So for work, there are two conditions. There should be a force, and this force should displace the object. Only then work is said to be done. Let us see in each of these cases if work is done. In the first case, Suma is swimming. Now, is there a force? Yes. She exerts a force. Is there a displacement? Yes. So work is done. For the next, an engine is pulling a train. Yes, the engine pulls the train, which exerts a force, and there is displacement. So work is done. Food grains are getting dried in the sun. Now, is there any displacement? No displacement. So work not done. A sailboat is moving due to wind energy. We have a force which is exerted by the wind, and the boat is moving, so work is done. A man tries to push a wall. Now here, when he tries to push a wall, he's exerting a force, but the wall won't move. There is force but no displacement, so no work is done. So what are the conditions for work to be done? There are two conditions. Conditions for work. One is there should be a force exerted. Number two, the object should move. There should be displacement. And three, which we'll discuss a little later, that the force should not be perpendicular to object. Should not be perpendicular to displacement, which we'll discuss a little later, the third point. So again, I repeat, what is work? Work is a product of force and displacement. When is work said to be done? When an object displaces, when a force displaces an object, work is said to be done. So we have two conditions for work, three conditions. A force should be exerted, the object should move, and the force should not be perpendicular to the displacement. So here we have a new quantity, and that is work. And remember, work is a scalar quantity. And let us find out the unit of work. And the unit of work is joule. Remember, it is joule. Now, how will you define 1 joule? Now, we know work equal to force into displacement. What if force equal to 1 Newton and displacement equal to 1 meter? Then what would have happened? Then we have work equal to 1 into 1 force, 1 displacement, which is 1 joule. So we can define 1 joule is a work done when a force of 1 Newton displaces an object through 1 meter. So 1 joule is the work done when a force of 1 Newton, here is 1 Newton, displaces an object by 1 meter. Here, the displacement is 1. Then we say the work done is 1 joule. Now the work can be of 3 kinds. We have positive work, negative work, and zero work. And we'll define each of them. Now we have work is said to be positive when force acts in the direction of motion of the body, which means if the force is in one direction and the displacement also is in the same direction, then the work done in this case is said to be positive. Here are examples of positive work. A boy kicking a ball, and when a boy kicks a ball, he exerts a force in the forward direction, and the ball also moves. The displacement also is in the same direction. This is the force, and the displacement also in the same direction. Hence we can say work done is positive. Here's another case where a man pushes a trolley, or he's pushing these boxes. Here too the force is in the forward direction and the displacement also is in the same direction. So work done positive. Let's study what is negative work. Now we get on to see what is negative work. Work is negative when force acts opposite to the direction of motion of a body. Like when you stop a car, stopping a car, we apply brakes to stop a car, and in this case the brakes apply the force in the opposite direction while the car moves for some distance forward. So the work done by the brakes is negative. So let's repeat it again. When force is in one direction and displacement is in the opposite direction, the work done is said to be negative. I will see what is zero work. Now in this case there is force and there is displacement, yet the work is zero. Work is said to be zero when force acts right angles to the direction of motion of the body, which means if this is force here in this direction, the displacement will be perpendicular. This is displacement, here is the force, and the angle between the displacement and the force is 90 degrees. In this case, work done is said to be zero. Here, this is an example of zero work done. There is a satellite. This is the satellite, and this satellite is moving around the earth here. Now the force is acting downwards, the gravitational force pulling it towards the earth. However, the displacement of the satellite is along the tangent, and the angle between the force and displacement is 90. So the work done in this case is 0. So work done on a satellite by the gravitational force of Earth is 0. Why? Because force is perpendicular to the displacement. Another example of 0 work is when a man carries a load. Here see there are two men carrying the load. The force is acting down, which is a gravitational force, and the displacement is perpendicular. So in this case work done is 0. Here work done will be 0 because it is equal to 0. The force and displacement are perpendicular to each other. Even for here, when the man is carrying a load, the force acting is downwards, which is the weight of the object, and if he's walking straight without changing his height, the displacement is perpendicular to the force. So 90 degrees in this case. Work here to be say work equal to 0. We'll now summarize. We have positive work is when the force and displacement are in the same direction. Then we have negative work when force is in one direction and displacement is in the opposite direction. And then there is 0 work when force is perpendicular to displacement. Here the angle, in this case the theta, we'll call the angle theta. Theta is 90. In this case the theta, see this is the theta. In this case the angle between force and displacement theta is 180. And here they're falling one over the other. So in this case the theta is 0. For positive work, the angle between force and displacement is 0. Negative work, the angle between force and displacement 180. For 0 work, it is 90.